Hi, welcome to Integral Calculus. In our previous lesson, we integrate a function using the basic integration formulas. These formulas may not suffice to integrate a given function. That is why we need a technique in integration. This technique is called integration by substitution. Suppose we are given an integrals in the form of the integral of f of g of x times g prime of x dx. We can transform this into another form by changing the independent variable x to u using substitution. We are going to let u as g of x, and the derivative of u with respect to x equals g prime of x. And our du is equal to g prime of x dx. And our original integrals is the integral of f of g of x times g prime of x dx can be written as the integral of f of u du. For example, evaluate the integral of the quantity of x plus 4 raised to the 5th power dx. In our solution, we are going to let u as x plus 4, and the derivative of u with respect to x is equal to 1, and our du is equal to dx. Therefore, the integral of the quantity of x plus 4 raised to the 5th power dx can be written as integral of u to the n du. By applying the theorem of antiderivative of a power, it becomes u to the n plus 1 all over n plus 1 plus c, and our n is 5. It becomes u to the 6 all over 6 plus c, and our final answer is the quantity of x plus 4 raised to 6th power all over 6 plus c. In our example number 2, evaluate the integral of x all over square root of x squared minus 1 dx. At first, we are going to let u as x squared minus 1, and the derivative of u with respect to x equals 2x, and our du now becomes 2x dx. We need to divide it by 2 both sides because our integrand is in the form of x dx, and it becomes du over 2 equals x dx. The integral of x all over square root of x squared minus 1 dx can be written as the integral of du over 2 all over u to the 1/2, and it becomes 1/2 times du all over u to the 1/2. By applying the laws of exponent, it becomes 1/2 times the integral of u to the negative 1/2 du, and it becomes 1/2 times u to negative 1/2 plus 1 all over negative 1/2 plus 1 plus c, and 1/2 times u to the 1/2 all over 1/2 plus c, and it becomes u to the 1/2 plus c, and our final answer is the quantity of x squared minus 1 raised to the 1/2 plus c. In our example number 3, evaluate the integral of e to the 3x dx. In our solution, we are going to let u first is equivalent to 3x. Our derivative of u with respect to x equals 3. And then our du is equivalent to 3 dx. We need to divide it by 3 both sides because our integrand is in only the form of dx. So our du over 3 is equal to dx. Therefore, the integral of e to the 3x dx can be written as the integral of e to the u times du over 3, and it is equivalent to 1/3 times the integral of e to the u du. Using the integrals of the exponential function, it becomes 1/3 e to the u plus c. And our final answer is 1/3 a to 3x plus c. Let us proceed to example number 4. Evaluate the integral of cosine the quantity of 4x plus 3 dx. We are going to let u equals 4x plus 3, and then our derivative of u with respect to x is equal to 4. Our du now is equivalent to 4 dx, and then we need it to divide it by 4, so it becomes our dx is du over 4. So the integral of cosine the quantity of 4x plus 3 dx can be written as the integral of cosine u times du over 4. And then it is equivalent to 1/4 times the integral of cosine u du. Applying the integral of trigonometric function, it becomes 1/4 sine u plus c. And then our final answer is equivalent to 1/4 sine the quantity of 4x plus 3 plus c. Let us proceed to example number 5. Evaluate the integral of tangent 3x dx. We are going to let u equals to 3x, and derivative of u with respect to x equals 3. And then our du now becomes 3 dx. We need to divide it by 3. So it becomes the dx is equivalent to du over 3. So the integral of tangent 3x dx can be written as the integral of tangent u times du over 3. And then it is equivalent to 1/3 times the integral of tangent u du. Applying the integrals of trigonometric functions, it becomes 1/3 times negative ln of the absolute value of cosine u plus c. And our final answer is equal to negative 1/3 ln of the absolute value of cosine 3x plus c.